Our third unit is on similarity and scale factor. To start off, let's review all of the information that is inside of a similarity statement. Here we have the similarity statement: triangle ABC is similar to triangle SRT. And we know a lot of things just based on the order of that similarity statement. For example, we know that angle A is congruent to angle S, angle B is congruent to angle R, and angle C is congruent to angle T. We also know that we can make ratios that compare the sides of the two triangles. For example, AB over SR, BC over RT, and AC over ST. And originally, we learned that these ratios are proportional to each other, which means that they should reduce to the same number. So they are all actually equal to each other. By setting the ratios of sides equal to each other, we made a proportionality statement. In this unit, we are going to construct proportionality statements that match up with sides of similar figures and use those proportionality statements to determine scale factors and to find lengths of missing sides. Here we have our proportionality statement, but we also have a diagram that contains information about the lengths of sides in the two similar triangles. We can substitute into the proportionality statement the information from the diagram to determine the scale factor between the two triangles. We know from looking at the diagram the length AB is 6, and the length SR is 3. We also know that the length BC is 5, and RT is 2.5. And finally, we know that AC is 9, and ST is 4.5. Now we can reduce these fractions to see if we have a common scale factor. 6 over 3 reduces to 2 over 1. 5 over 2.5 also reduces to 2 over 1. And 9 over 4.5 also reduces to 2 over 1. Since each of these fractions reduces to the same value, we are sure that we have a true similarity statement. The value that each of these fractions reduce to is called the scale factor. And it is read like this: triangle ABC is similar to triangle SRT with a scale factor of 2 to 1. The scale factor can be written as either a ratio 2 to 1 or as a fraction 2 over 1. It is important when you're setting up your fractions that the first listed polygon be put on the top and the second listed polygon sides be listed on the bottom of the fractions. This will ensure that your scale factors will match up with the order of your similarity statement. Let's see if we can find the scale factor between these two similar polygons. Since there is no similarity statement, we will list out the lengths of the sides of the smaller polygon from least to greatest. So 3, 3, 5, and 7. Then beneath that, we will list out the lengths from the larger polygon from least to greatest. 12, 12, 20, 28. Now we notice we have a repetition of two of the terms, so we can actually cross one of those terms out. If 3 over 12 works once, it will work twice. Now we can attempt to reduce each of these fractions into a consistent scale factor. If you divide the numerator and denominator of 3/12 by 3, you get 1/4. 5 over 20 reduces to 1/4. And 7 over 28, dividing the top and bottom by 7, also gives you 1/4. Since each of these ratios reduces to the same value, our scale factor is 1/4. Since we have no markings for the vertices of these polygons, we can simply say the scale factor of the smaller shape to the larger shape is 1/4. In this example, we have a similarity statement. ABC is similar to TPR, and we have diagrams of triangle ABC and triangle TPR. And what we're going to do is verify that these two triangles are indeed similar with the measurements that were given in the diagram. So first, we're going to break up our similarity statement into all of its congruent and proportional parts. So angle A should be congruent to angle T. Angle B should be congruent to angle P. And angle C should be congruent to angle R. And then our sides that should be proportional are AB, BC, and AC should be proportional to TP, PR, and TR. We can now substitute the values from the diagrams into our congruence and proportional statements. So angle A measures 46.7 degrees. So we can put that in. And hopefully that equals angle T, and it does. Angle T is right here. It's 46.7 degrees as well. Then angle B is 104.3 degrees. And that also equals angle P, which is 104.3 degrees. And finally, angle C is 29 degrees. And that matches up with angle R, which is also 29 degrees. So all of our angles are congruent to their corresponding angles. Now we have to make sure that our proportionality statement is also true. So AB, the measurement from A to B is 6. The measurement of TP is 4. The measurement of BC is 9. The measurement of PR is 6. The measurement of AC is 12. And the measurement of TR is 8. And if all of these fractions reduce to the same scale factor, then we know that our polygons are indeed similar. For 6/4, we can divide the numerator and denominator by 2 and get 3 over 2. For 9/6, we can divide the numerator and denominator by 3 and also get 3 over 2. And 12 over 8 reduced by 4 is 3 over 2. So since each of these ratios reduces to 3/2, our scale factor is 3:2. By showing that all the corresponding angles are congruent to each other and all of the corresponding sides are proportional to each other with a scale factor of 3/2, we have verified that these two triangles are similar. Here we have two polygons and we are told they are similar to each other, and we are asked to find a missing side length. But we are not given a lot of information about each of these. The most important thing we are given, however, is the scale factor from A to B is 5:6. And I can use this information in order to find out what the missing question mark side is. So I know that my scale factor is A to B, which means A should be on top and B should be on bottom. And the ratio is 5:6. So 5 should be on top and 6 should be on the bottom. And looking at my shapes, A is the shape that I know that length is 20. B has the missing side, so I can even write that in. My A length is 20 and its corresponding side in B is a question mark. So now we can just use a piece of this proportionality statement in order to find the missing side length. We'll use the part that has the scale factor and the part that has the 20 over the question mark. So 5 over 6 equals 20 over question mark. We can then use the cross product property to find out that 5 times the question mark value will equal 6 times 20. Then to completely isolate our variable, we will divide both sides by 5. And this will cancel on this side. Now our question mark is completely by itself. And we're left with 6 times 20 divided by 5. And 6 times 20 divided by 5 is 24. So our missing side in shape B will be 24. Now we're going to use similar polygons to find missing side lengths. Here we have two quadrilaterals and we have a similarity statement. ABCD is similar to KGHJ, and some values are given in the diagram and some of them have variables. So we are going to use a proportionality statement and the scale factor to find the missing values for the different side lengths. Since we have a similarity statement, we can write a proportionality statement. AB, BC, CD, and AD will all be proportional to KG, GH, HJ, and KJ. Now we can substitute the side lengths in our proportionality statement with what we find inside the diagram. AB is 6, while KG is 2 in our diagram. BC has an expression for it, x minus 7. GH is 3. CD is 8. HJ doesn't have a value. We'll just keep it as H and J, but those are not values that we're looking for. We're looking for X and Y. And finally, AD is 4.8 and KJ just has a Y variable in it. Now, when you have a proportionality statement like this that has multiple different variables in it that you have to solve for, it's not important that you look at all 4 terms at the exact same time. For example, the 8 over HJ, we're actually not going to use that in finding the values of X and Y. It's not going to play an important role for us because it has a missing term, so it's not going to help us do anything. What's really important is that in your proportionality statement, you have at least one term that has a number on the numerator and on the denominator that you can reduce or solve in some way to find out what the scale factor is. And in this, we have the first one, which is 6 over 2. If we reduce that, we can then get our scale factor and use that to find what X and Y are. So let's reduce the 6 over 2 to figure out what our scale factor is. 6 over 2 reduces to 3 over 1. And that's going to be the scale factor for each of the sides in these two polygons. And that's because we know that they're similar. We have a similarity statement, and all we need is one set of corresponding sides to reduce to our scale factor to know that that will be the same scale factor for each of the other pairs of corresponding sides. So now I can make a proportion where 3 over 1 equals x minus 7 over 3. By solving this proportion, we'll be able to find what the value of x is. So we can use the cross product. 3 times 3 is 9. And then 1 times x minus 7 is just x minus 7. By adding 7 to both sides of that equation, we'll arrive at x equals 16. To find the value of y, we're going to use our scale factor, which is again 3 over 1, and set that equal to the last part of our proportionality statement, 4.8 over y. By using the cross product, we can find that 3 times y will equal 4.8. And dividing both sides by 3, we get y equals 4.8 divided by 3 is 1.6. Thank you for watching the video. Hopefully this will help you find scale factors and use them to solve for different sides of polygons that are similar to each other. Good luck!